Okay, so we're going to talk about multiplying perfect square polynomials, and I'm going to go back to some older rules about what it means to be an exponent or a power on something. And I'm going to compare and contrast this guy and what that means. And so what I need to do is describe what the power of 2 on this actually means. And what it means is that I have the x twice. Because power is on what it touches. And it's not touching the 3, it's touching the x. And then when I look at this guy over here, so I have this guy over here, the power is touching the parentheses. And that means that I have the parentheses twice. So I have 3x and 3x. And this is the same as saying I have 9x squared. So they're not the same. The parentheses makes a difference. So I want to talk about this guy down here. So we're going to talk about this problem right here. And I'm going to be able to do the math on this when I recognize that the power of 2 is on the parenthesis, which means that I have the parenthesis twice. Okay. So I'm going to say, well, this means that I have this parenthesis group twice. So I have 5x minus 2 and 5x minus 2. This is not the same as trying to quote-unquote distribute that 2. That's not a thing. So I'm going to say, this is what people try to do, not 5 squared x squared minus 2 squared. Like, that is not true. This is not a thing. Don't do that. That's wrong. You have to do the multiplication where you distribute it. You can use something people call FOIL. I'm just going to multiply things twice and combine like terms. So you have multiple steps to this. You can't just distribute powers. So what I'm going to do is I'm going to multiply this 5x times everything inside here. Okay. And that's going to give me a 5x, and then I'm going to write down everything that's left, 5x minus 2. And then I'm going to distribute this negative 2 times everything inside of here. Okay. So I'm going to say I have, let's try to get this gone. I've got this 5x times the first parenthesis group, and I have this negative 2 and the 5x minus 2. Okay. And when I multiply polynomials, I multiply the coefficients and I add the powers on common basis. So I'm going to write down that rule and say I multiply the coefficients, and then I add powers on like bases. Okay. If I want to add powers on like bases, I have to put my powers in where I can't see them. This is really an x to the 1, and this is an x to the 1, and this is an x to the 1. If I can't see that there are powers of 1 on my x's, I will forget to add the powers there, so I write them in. I do myself a favor. So I'm going to multiply the coefficients first, and then I'm going to add the powers when I have like bases, and that's going to be x to the 1 and x to the 1, which is x to the 2. Okay. And then I'm going to move to the next one and go, I'm doing 5 times negative 2, and that's going to give me negative 10, and there is only this guy right here has an x term, or x part of the term, and this one does not. So I'm just going to write down that I have an x to the 1. Okay. I'm going to do the same thing on the second one. I'm going to distribute that negative 2 through, and so I've got a negative 2 times 5, and that's going to be a negative 10. But only this guy has an x in it, so I'm going to write down that I have an x to the 1. And then I'm going to do my distribution with my negative 2 and my negative 2, and a negative times a negative is a positive 4. Okay. Now, I've almost done. What I need to do now is I need to combine my like terms, and my like terms are these two right here. I have this guy and this guy are like terms, and they're like terms because the power on the x is the same. If the power on the x isn't the same, then you can't combine them. So this is going to be 25x squared, that's the first one. Negative 10 and negative 10 is negative 20 x's and 4. And that's my answer, which is not what I would have gotten over here if I'd tried to do this other thing that's not a thing.